Hello everyone, today we're going to take a look at creating this little terrain generator that we previously made in P5.js, but we're going to do it using Rails 7 and more specifically Stimulus to have all of this running inside of a Stimulus controller. Now of course this terrain generator uses a simplex noise implementation which allows you to procedurally generate terrain similar to how games like Minecraft does it, and then as you play with the settings you get completely different maps, etc. It really depends on what you're trying to generate. You can then, scale this up, maybe add some rivers and some valleys and some trees, or you can change it to a 2D implementation similar to the one I have right here, where you have, caves and ores. In this case, you have to mine several ores to get the wind condition. You can spawn water that flows, and, if this were a game like Terraria, you could go left and right and just continue to explore the world. In this case, we can't do that. We just, run around and mine blocks until we win. And we've covered this in a video as well. But the first step is creating this terrain generator inside of a Rails application. So let's go ahead and let's take a look at how that would look using Rails 7 and Stimulus instead of plain old JavaScript. To do this, we're going to go ahead and do a Rails new. We'll call this video. I'll hit Control plus a couple times. And we're just going to pass in -J for ESBuild and -B for Bootstrap. Not necessarily required, but I do like to cover it just because it seems like every time I do, someone goes, oh, that's how you do those things now. Now, in terms of the actual Stimulus and Rails, it's going to just be a pretty basic controller. We do have to set up a, make sure we're connected properly. And that's, just a quick method and some HTML that we're going to create. And then for the rest of it, we can do it inside of a Stimulus controller. But of course, we can also use API requests if we so desire to make this a lot more powerful, maybe for some type of persistence where you could save the generation state or something. But to do the basics, all we have to do is create a controller, call it pages, call it home. That'll give us our home page. We can now do a Rails G Stimulus, and we'll call this terrain. So that'll generate a Stimulus controller called terrain controller. And now if we go ahead and open this up in code dot, we can go ahead and take a look at this. In terms of the routes here, we can go over to our config and our routes.rb. Let me hit Control plus a couple times and hopefully VS Code will catch up. I don't know why it's so slow right now. Let's come over to routes. I'll hit F11. In here, pretty much all we have to do is set up the root of the application. We want the root of the application to be the pages controller and the home action. You then come over to our app, our views, our pages, and our home page. And in here we can bind this the same way we would bind, any other Stimulus controller. So here what we're going to do is we're just going to create a content tag for a div. We'll give no content inside of this div, so it's just going to be an empty container. Then we'll pass in some data. We'll close the parentheses. For the data, we just want to say the controller is going to be the terrain controller because that's what we called it. And then we want to wrap everything inside of this terrain controller so that we can use it just like some regular old, HTML Stimulus stuff, right? Now for the overall page, because we're using Bootstrap, that means we can do a .container.mt-3, which will give us a bit of a move to the right, and it'll center everything, and then it'll move everything down by 3 units. So if we come over here and we run a bin/dev, which is how we start the server with the Bootstrap and ESBuild, we can then go ahead and refresh, and on the localhost port 3000, you'll see we don't actually have anything because there's no content in here. But we can put the word test in here just to give this div some content. And now if we get rid of this do block and this end block right here, we can save this, and now our test is going to appear. Because we have the do in the end, that's not going to be there. So we're just going to leave this empty, but at least we know it's showing up on the page. Now, because we're going to be using Stimulus, we should probably open up our web dev tools. We can now come over to the side and come into app, JavaScript, controllers, and the terrain controller. And for now, let's just console.log that we are connected with this controller. If we refresh, you'll see down here, we have connected appearing in the console. So now our HTML is connected to our Stimulus controller. Let's go ahead and let's add some stuff to actually play around with a terrain generator. We're going to be using plain old JavaScript for this for the canvas, so we're not going to have access to the cool P5.js stuff. Unfortunately, that does mean we're going to have to do some lower level, canvas calls. We can't just have P5.js do like a draw loop for us, but that's fine. We're going to come down here, create a row, create another row, and then inside of this other row, we're going to do a content tag for the canvas. We'll put note text inside of it again and pass it some data. And then inside of this, we're just going to say this is a terrain underscore target of canvas. And you'll see what that does in a second. And then down here, let's give it a width of, I don't know, 350 and a height of 230. And I think those are in pixels. So we can do that, come over here and refresh the page. And now we can select or hover over this canvas and we can see how big it is. So that looks pretty good. Now let's take a look at what this terrain target does. Effectively, instead of using like a document.getElementById, we can define a static list of targets in our stimulus controller. And inside of here, we pass in a string that has the word canvas. Now we can come down here and we can grab that canvas by just saying this dot canvas, which is the string right here, target singular because it's a single target. A little bit of a strange usage. I don't really care for it, but that's just the way this works. Now that we have this, we could get the context for the canvas, and then we can, I don't know, set the, let's give this like a set background color to red, right? It'll set the fill style, and then we can draw like a rectangle inside of it. Let's go ahead and save that. And then we can come over here and refresh. And now we have a red rectangle appearing inside of our canvas. So that's just one example, but we want to generate this terrain. So how do we do that? Well, the first thing that we probably want to do is import open simplex noise. So if we stop the server, we can do a yarn, let me full screen this, yarn add for open dash simplex dash noise. And what open simplex noise is, you might be familiar with like Perlin noise where you use it to generate procedural terrain. Well, there was a simplex noise, which is like a faster alternative created by the same person that was, I believe, put under like some kind of patent. So then someone else made an open source implementation, which is the open simplex noise. So it's a little bit faster than Perlin noise, makes some better looking terrains, and it's open source. So, you know, we take those. Let's go ahead and run a bin/dev to start the server again, refresh to make sure we didn't break anything, and then we can go ahead and import that. We'll come in here, we'll import the, I think we have to import the make noise 2D. There are also 3D and 4D options if you're so inclined. And then we just do this from open simplex noise. Okay, so we have that. Now, what we probably want to do is we can add some like sliders to play with some settings and some other stuff. So the overall structure is going to be, we're going to have like a node. So we should probably go ahead and do that. Let's create a class down here. We'll call this the node class. And then we can give this a constructor. It's not going to take in a Z, but it will take in an X and a Y. As for the Z, this is going to be a node type. And that will just be a this.node type equals node type. Now what's our node type going to be? Well, the node type is going to be another class, which we'll just define down here, which is going to take in a name and a color. So you can think of this as like grass, and the color will be like the hex value for green, right? So like if it's RGB, then it would be the hex value of, you know, 00FF00, because these two are for the green, something like that. We'll make this like grass, make it a bit more clear, just as an example. So that's our nodes right here. We now have to create a graph for these nodes or a grid for these nodes or something. And we're also going to have to create like a list of colors. So let's go ahead and let's get rid of this code right here because we're not going to be using it anymore. And let's just think about what we need to do. So the first thing we probably want to do is something like this, dot instantiate noise config. Then we'll have to actually create a noise config. So we're using this because we're inside of this class. This is all going to be like some class level calls. So we're going to be using a lot of this and that. So just, I don't know, bear with me. As for a noise config, you can find a lot of tutorials online, but effectively what this is it's just going to be a object, regular old JavaScript object. And in here, we're just going to set up some stuff. We're going to give it a seed. I like to default it to 1337 because I'm 12. The seed is just going to be the thing we pass into the simplex noise generator, similar to like if you use math.random, you can give it the same seed so you always get the same random numbers. We're doing that so we always get the same random terrain. You can then make this a slider or an input or something for the user, and it would give you a different random terrain each time. We're going to give an amplitude. That's just going to change how big the numbers are. If you have like a regular terrain, like a 3D terrain, that's going to change how high the mountains are and how low the peaks and valleys are. We'll give it a frequency. I'll set it to 0.02. These are just numbers that work for me as I play with them. We'll then give it an octaves. Frequency, of course, is how many times like the mountains and islands occur, right? How many times the features occur. So a lower frequency gives you a smoother terrain. Octaves are going to be how many like layers of noise we're going to layer on top of each other, which is what gives it those finer details. Then we have to give it a persistence and a lacunarity. For the persistence, I set it to 0.1, and for the lacunarity, I think I set it to like 6. So what these are going to do is every time we do the octaves, we're going to apply some persistence and some lacunarity, which is just going to have like a bit of a fall off. So we're going to apply the amplitude and the frequency in decreasing amounts for each layer, so that each layer's details are less impactful than the previous ones. So that'll give you like that compounding effect where the more octaves you have, the more detailed your terrain looks. So if we come over here, if we give it like a octaves of 1, you'll see we don't really have a lot. If we do an octaves of 2, we start to get more details, and I can even refresh here. And if we go up to like 4 octaves, for example, you start to notice that there's some really fine details here along these shorelines where we have these like small little pixel differences. As we crank up the persistence, you can see what happens is you get like a lot of that pixelated granularity. And then for the lacunarity, same difference. If we come down to 1, you'll notice that there's like almost no details anymore that are like at a fine level. So, same concept really. Okay, we have that. That is now our noise config. The next thing we want to do is instantiate our noise types. So come up here and say this.instantiate noise types. For the noise types, we're just going to be creating these classes right here, right? So we have to do that for each of our blocks, or our node types, I guess. So say this.node types. Oops, it already auto-completed a bit. And for this, what I want to do is have a different node type for each one, but I want this to be a bit more accessible. I'm going to make this an object, and then I'm going to set the air one. So we'll say air is a new node type, the name of air, and the terrain.colors.air. So the terrain.colors, we can actually give stimulus controllers a class name. So we can say export default class, we'll say terrain. So now we can call terrain.whatever to access this. And then for the colors, we can define some colors for different blocks. We can create another static variable up here, call it colors, set it equal to a JavaScript object. And then in here, we can choose different values. Now, if it's an empty block, we can give it air. And if it's a grass block, we can give it, the color green. I'm going to paste in a couple more here for sand, stone, water, and snow. And I just kind of made these up or Googled them to find something that looked good. So feel free to copy these over if you're so inclined. But now that we have those, we can come down here and we can access these just like the code is suggesting. Now we're going to do the same thing here with the air, and I'm just going to paste these in. We're going to have one for grass, sand, stone, water, and snow, which is going to be grass, sand, stone, water, and snow. And then we just grab them from our colors object just like that. So that gives us a bunch of customizable options. Words are hard. And we can use those to sort of color our terrain now by accessing the node types color, which also means when we generate the terrain, we have these values coming back from our noise. They might be like 0.3 or 0.5. We want to make sure that those correspond to roughly the range where we want to see grass, sand, stone, or water. So we might want water to be like 50% of the world. So at like 0.5 or lower, we make it water, and then above that, we make it sand, and then maybe we make it grass, then stone, and then snow. You get the idea. So that gives us our initial node types. Let's come up to the connect method. So after we have the initial node types, we now want to set up some input values. So we want some sliders up here, maybe similar to these, and we can use some stimulus magic for those as well. So for the input values, we're actually gonna have to create the HTML for this. And this is going to be a little bit repetitive, unfortunately. You could probably abstract this a little bit, but what I'm going to do is come up to this top here, and in here I'm going to set all of our sliders and stuff. So what we can do is we can say this is going to have a .col, and then inside of each of these columns, we're going to have 2 content tags. So say this is going to have a content tag for an input. This will be for our seed with a type of range. So this will be a slider. We'll give it a min of 0, a max of, I don't know, let's just put a couple zeros here until we're done. And then we want to give it some data. Now for this data, because we're using the terrain controller. We want to give this a terrain underscore target. We'll call it seed. And what that'll allow us to do is inside of our terrain controller, just like how we grab the canvas, we can now grab the seed, just like this. Now, for the actual target though, I want this to be a specific type of seed. I'm gonna say this is a seed input because I also want to create a seed value. So we can copy this, paste it down here. I'll tab this back. This will be of type div. There won't be anything inside of it, and it's not going to have a type or any of these other items, but we are going to change this to a value. So we now have a seed input and a seed value. And for our terrain target, our slider, when we change this, we want to call a stimulus method, which we'll just say on change, call terrain, and then so that's like the controller with the update action. And we'll fire the same update action for each one because we're going to have to like re-render, everything when we do this. So we can go ahead and save this, come into our controller. We now have a seed underscore input, and we have a seed underscore value that also needs to go in quotes. And now we want to repeat this multiple times because we're going to have multiple instances of this same logic where it's for different, input types, right? We are going to have to configure these values though a little bit. So what we're going to do is we're going to have one for the seed, then we're going to have another one for the, not the scale, but we're going to have one for, let me backspace this, the amplitude. So we'll come in here, we'll change this one to amplitude. For the amplitude, we probably want this to be between something like 0.01 and 2, and then we want to give this a step size of 0.01. We can then change this to be the amplitude target or amplitude input and the amplitude value. And hopefully you can see where this is going now. We come down here, we add another one. This one will be for our frequency. We'll have a frequency input and a frequency value. And then we can go ahead and close this div. And then after we're done with this, we can come down here. We can create another one. And this one will be for our octaves. So we have our octaves between 1 and 10. We call it octaves input and octaves value. We then close this div. We can go ahead and save this. We can come down here again, create another one, .call, hit tab, come over here, and now we need persistence. Exactly. Good job, GitHub Copilot. We come down here, we close persistence, we create another div or another call. We hit tab. And for this one, this is going to be our lacunarity. Then we can come down here and close this. So now that we have all of those, we come over into our terrain controller, and I'll just hit enter on this because we're going to have a few more joining us. Let me open up my notes for this, and let me copy all of these over. So we're going to have a amplitude input, amplitude value, frequency, octaves, persistence, lacunarity. If you're using GitHub Copilot, be careful because the first time I tried this, it kept misspelling persistence. So it must be trained on like the wrong spelling of persistence, which is pretty funny until you run into a bug where stuff doesn't work and you can't figure out why. So that's just something to be aware of. But now that we have that, we can use this initialize input values function. So we'll come down here and create it. And what we're doing with this is we're going to set all of the values for those sliders to be whatever our config is set to, because our config is called first. So what we're going to do is we're going to call this .seed underscore input, which is what it's called. And then capital T target .value is equal to this .config.seed. And then after we do all of these, we also want to set the inner text to be equal to whatever that number is. So our slider is going to be the actual value, and our text is just going to be the thing that tells the user what the slider is set to. So if we do that, we can now refresh, and we'll have all of these things appearing here. But we're going to run into an error here where it tries to reference an undefined method update, because the event that happens on change when we do this is called update, and we don't have an update method in here. So of course we come down here and we create an update method. Now what does this update method need to do? Well, the first thing it wants to do is call a function or call a method that we name set noise config to input values. Now this one's going to do the opposite of what the initialize one does. So for this one, we set this up. And then in here, we want to, instead of doing input target.value equals config.value, we want to do this dot noise config dot seed, which is the second half, is equal to this dot seed underscore input target dot value, which is the first part. So we're just flipping it. Unfortunately, a necessary evil here, but we paste these in, we do it for all of them, and then we do it for all of the texts as well. And now we are initializing these appropriately. So after we have that, the next thing to do is we're going to have to set up the logic to actually create this terrain. And after we create this terrain, we're then going to have to set up that same logic in here in the update method so that when we change it, we like recreate the terrain. So in our config, or inside of our connect method, sorry, after we do the initialization, we then want to do a this dot, we'll call it construct terrain, something like that. We can come down here and say construct terrain. And in here, what we want to do is we want to start by creating a noise with our make noise 2D that we imported earlier. We pass in the seed. After we pass in the seed, we then want to, actually, it's not going to be this dot seed. It's going to be, we want to use this dot noise config dot seed. There we go. So after we do this, we then want to create a grid. We'll say this dot grid equals this dot, and we'll call it generate terrain. And then we are largely good to go. So inside of our connect, we're going to call this, and then inside of our update, we're going to call this as well. So whenever we change stuff, it happens in both, or it happens in the update, and on load, it happens in the connect method. So that's good. But what does the generate terrain actually do? Well, generate terrain is going to be another method that we create. We call it generate terrain. And in here, what we want to do is create a grid, set it equal to an empty array. And this is close, but not quite what we want. Basically, we want to do a for loop. We set this to loop through the canvas target.width. And then for each of these, we need to create a grid X. So we're just creating a element inside of the array because it's going to be a 2D array. We then do a second loop that goes through the canvas height. And then what we do is we say grid xy is equal to this dot get node x comma y. Now get node is going to be another function we have to create down here. Call it get node, takes in an x and a y. And what this is going to do is it's going to call or create a const node type, which is going to be equal to this dot get node type, pass in the xy. And then after it gets that node type, it's going to return a new node with an x and a y coordinate and that node type. So now, of course, we have to say, what does get node type do? It's going to take in an x and a y. And then it's going to do a const, right here, a const noise value equals this dot get noise value. So what does get noise value do? Well, get noise value is going to have another x and a y input. And this is where we do our final loop for the octaves, because we do a loop for the X, we do a loop for the Y, and then for each of those points, we have to, you know, loop through another like octave for each of the octaves. So for this, we grab the persistence, we grab the lacunarity. Let me just copy this over so it's faster. We then have the frequency, and we have the amplitude. And then what we're going to do is we're going to create a for loop again. So you have to think at this point you are 3 nested for loops in. So this is going to be, you know, O of X times Y times your octaves for your runtime. Then we're going to have to create the noise value. And the noise value is the variable we initialized to 0 at the top. But we're going to set this equal to plus equals this dot noise. So for each iteration through the noise algorithm, it's going to add the result. And it's going to add X plus the frequency, or sorry, X times the frequency. I don't know where plus came from, and Y times the frequency. So we're applying the frequency into this input for the noise, and this will return a value between 0 and, or sorry, -1 and 1. Now that value of -1 and 1, if we want higher mountains or deeper oceans, for example, we then want to multiply the output of this by the amplitude. After we do this, we then want to have our fall off. So for our local frequency, we're going to set that to be times equals the lacunarity, which is going to be a bigger number. You're going to have like a fractional frequency times a bigger number. So 0. I don't know, 0.2 times 5, for example, or times 10. And then you're going to have your amplitude. So let's say 2 times a fractional number of like 0.01. So that 2 will very quickly approach 0 in that case. After all of that's done, we then have a value that's going to be, between -1 and 1 times the amplitude. So if your amplitude's 10, it'll be between -10 and 10. We then want to normalize this a bit so we can work with the values a bit more. So for that, what we'll do is we'll say let normalized noise equal this dot normalize value, which will take in a noise value. It'll take in the minimum range and the maximum range of that noise, which in this case, with a amplitude of 1, it's just going to be, the values of -1 to 1. What you could also do is you could say this times the amplitude, right? Something like that. In this case, we're just going to keep it simple, normalize the value. We then come down here and we say normalize value, which is going to take in the value, the min, the max, and then we're actually going to do some extra here, which is going to be a new min, which we'll set equal to 0, and a new max equal to 1. After we have all of that, we can then do some math here where we return the value minus the minimum divided by the maximum minus the minimum times the new max minus the new min plus the new min. And that is just a very fancy way of generalizing this into a normalized value between our range of 0 and 1. And after we have all of that, we can then say return the normalized noise. So that's going to give us our noise value. It's a lot of math. Unfortunately, that's just how these procedural things work. But after we have that, we can then do a check to see like what node type this needs to be, right? So we say if the noise value is less than, let's say 0.5, which will be half the terrain, we then want to return this node types water. And then we're going to repeat this logic all the way down here with a bunch of else ifs. So let me get rid of this. We'll say else if it's less than 0.55. So this is only for 0.05 of the terrain. We want it to be sand. So this will be right next to the water and right next to whatever's after it. We'll say whatever's after it is grass. So in this 15 range right here will be sand, and then it'll be grass for another 15, or we can even say until it's at 0.9 maybe. And then after that, we'll set it to stone, which will give us our mountains. And then after that, we'll set it to snow as an example. So if we, actually, it's not going to draw anything. I don't know why I'm exiting out of here. If we come up here, we now have our get node type happening. It's getting our node type that is doing all of this fancy math. After our get node type happens up here in the generate terrain, we then want to come down here and just return this grid. This grid will then get sent into the this.grid. And now for the fun part, we can take this and say this.draw terrain. And for the draw terrain function, we can just do that right down here. We'll say draw terrain. This is where we actually do the drawing onto the canvas. So we'll say const context equals this dot canvas target, which again, we're getting from our static targets. And let me make sure I spell this right. And then we can say dot get context, and we want it to be the 2D context. After we have that, we have to iterate through all of these, which is going to be a for loop, but this is going to be for this dot grid dot length, I believe. And then we want to do a for where we let y equal, and then it's going to be this dot grid x dot length, and then y++. And then for each of these, we want to say const node equals this dot grid. We get the node. We then say the fill style should be the node color, which is actually got to be the node type color. And then we want to do a fill rect where the x and y are the positions and the size is 1 pixel each. We save all of this, come over here and refresh. We'll get an error for the persistence input in our terrain controller. So this is going to error out somewhere, which means we probably have a typo somewhere or some other issue. It could even be this. Let me save that and refresh. We are still getting a persistence input. So let's come up here. We have our persistence input right here, and we have a persistence over here. So this is what I meant. Again, you get these typos with with how Copilot does these things. So let's change this to a persistence and a persistence. Make sure that's good. Come over here and refresh. Oops, refresh. And now we get a error for the missing target element canvas for the terrain controller. Oh, I think I know what the problem is. Let's come down here. We have this div right here for our row. This might need to get moved up a bit. I think here, maybe? Something like that. Because this row and this row, I think, need to correlate. There we go. So it might have just assumed it was like out of it. So if we come in here and refresh now, we now have our little canvas being created. And now if we move this slider, we'll get some more errors where construct terrain is not defined. So we have to use this.construct terrain, which will happen in our update method. You just come in here and we say this.construct terrain. Now if we refresh, hit F11, if we change this, we should get a different terrain, and then we can, you know, mess with the settings and blow everything up like we normally do. So now if we up the octaves, up the persistence, we can down the linearity, something like that, we get, you know, our terrain generating just like we would expect it to. So that's sort of how you can do something like this in, you know, a stimulus controller. Obviously, you'd want like more fine-grained results. You'd probably want to refactor these into like their own files or something. You don't need to have these inner classes here, but you get the idea. Hopefully this was interesting, seeing how this can be moved from like one framework to another. It's, you know, basic JavaScript at the end of the day, but stuff like the, you know, the... In this case, we ran into issues with the targets because the HTML was in like the wrong location, or, you know, just using the targets in general, or like having to, you know, define the class name, stuff like that. It can be a little bit confusing because stimulus is just this thing that's presented as if it's magic, but at the end of the day, it's just regular JavaScript, right? That said, hopefully this was interesting. Hopefully this was helpful. And if you do celebrate Christmas, hopefully you have a, you know, a Merry Christmas, Happy Holidays, whatever. Enjoy your day. And I will see you in tomorrow's video.